Jeff is the creator of grassrootsmapping.org. He designs mapping tools, visual programming environments, and flies balloons and kites as a fellow in the Center for Future Civic Media, and as a student at the MIT Media Lab's Design Ecology group, where he created the vector mapping framework Cardigan?
Either. Cardigan.
Okay, cool.
Cool. I guess I was going to give a short talk about some of the projects that I've used balloons and kites to make maps, in which I've used balloons and kites to make maps, different places around the world, and then was going to try to open it up for questions, and then actually we have some balloons outside. So if, if we, depending on how much time we have left, we can either go outside and do a flight, or we can all grab the best sandwiches and then go outside and do a flight. We'll just kind of play it by ear. My background is well, I guess going back far enough, I did an undergraduate in architecture, where there's a lot of map making in the pencil and paper kind sort. And I got more and more into programming after graduating, and started writing a lot of map frameworks, map software. And increasingly was kind of both frustrated that the mapping experience in the digital side tended to be at a keyboard indoors, and also interested in where maps came from in terms of where the information is actually produced, who produces it, and why. And I got more and more into this idea of maps as a narrative or a rhetorical tool rather than as a direct representation of the world. So those thoughts and that kind of research led me in the direction of trying to make my own maps. And I thought did a lot of reading about who owns satellites, who pays for them, how do they work, things like that. And just to get back to basics, I read about some other MIT student who had done one of these high-altitude balloon flights where they take like a styrofoam cooler and they put a camera in it and they just let it go, and got some really cool imagery. And I thought, well, that's cool, but for mapping a specific site, could we attach a string to that, And we just started flying balloons at around lunchtime. And basically, over the past year, we've kind of refined this tool set. And I want to make it very clear that I've worked with a bunch of organizations, local groups, environmental groups, educators, classes of students, stuff like this, all around the world. And it's through those collaborations that this tool has, I think, been refined, cut down in cost, simplified, and also not just made less, but made more, in that we've made maps of larger and more impressive sites. The biggest one is, just to give you a sense of literally what I'm talking about, you take a kite or a balloon, and you attach a camera to it, and then you let it up in the air. It's not actually a very new idea. Nathan Craig has been doing this for I don't know how many years. Not that long. Well, kite aerial photographers have been working for probably a couple decades. And balloon aerial photography, I think the first one was in like 1860. It was like as soon as they could get a balloon in the air, they put a camera on it. And I'm assuming they had a piece of clockwork to like fire the camera after an hour, and you get one picture, something like that. But what we can do nowadays is that we have very, very cheap cameras. You can buy a brand new one for less than $50. That's 10 megapixels. It's just crazy. I don't know, I guess polymer design maybe has led us to better kites and balloons, but I mean, whatever. One of the biggest uses of this has been in the Gulf of Mexico after the oil spill. I started working with a group called the Louisiana Bucket Brigade. And the Bucket Brigade is an environmental group. They're specifically interested in air quality and the negative impact of petroleum pollution, petroleum extraction and pollution on local communities. So they have really good relationships with a lot of different communities around the Gulf Coast, specifically in Louisiana, who are both affected by petroleum and also who are employed by the petroleum industry. So it's a complex kind of social issue as well. And we just started flying kites and balloons about a week or so after the spill to see if we could capture imagery of oil hitting shorelines and its effects, and see if we could do some slightly more quantitative assessment of how that's happening. Granted, you can't image a very large area, maybe like a square mile is an ambitious goal, but you can do it at very high resolution. So those of you who know about like remote sensing probably know that say 50 centimeter imagery is something you can generally expect to see on Google Earth, for example. That means that every pixel of the image represents 50 centimeters in the real world. And that's pretty good. Probably the CIA has a bit better. Our imagery tends to top out at about 3 centimeters per pixel, meaning that every pixel of our image is 3 centimeters in the real world. So we're already beating, you know, say Google Maps by tenfold at least. And in a lot of areas, because we have up-to-date data, as in we can gather it on demand, you should really compare it against something like the MODIS sensor that was being used to survey the spill. The MODIS is a NASA sensor, which is fantastic, but it has a resolution of 250 meters per pixel. So, you know, orders of magnitude, I suppose. Of course, we're not taking pictures of the entire Gulf of Mexico. So, this is the kind of picture you tend to get. It has a lot to do with gigapan imagery because we take a lot of pictures and we move the camera. We don't change the angle, or we try not to, but we move the person or the boat or whatever's towing it, and we get all these different pictures. And unlike the kind of very tidy gigapan ordering, our pictures are from all different altitudes, they're all different angles, all different lighting conditions. Sometimes they're from different days. You take 2 or 3 days to actually complete a big map. And we're trying to bring this all together, rectify it, and we're trying to make sure that that process is participatory as well. So we don't use automated stitching for a variety of reasons. I think it's possible, but most of the assumptions that have been written in software are based on the idea that you might be doing it from a consistent distance or a consistent angle. You know, there are good algorithms. SIFT, what is it? Scale invariant feature transform, is it, you know, can theoretically account for a lot of these things. But in general, manual stitching is not that hard, and it's more it's more involved on the part of the people making the map, and you know, it goes hand in hand with close examination of the information. So this is done in Photoshop with some really terrible data, and that was from about 4,000 feet actually. This is from about 1,000 feet, and it's pretty good actually, also in Photoshop. When basically we take screenshots of Google Maps, really basic, throw them in the background layer in Photoshop, and then manually stretch things on top of that. That's for a few reasons. Google Maps is spherical Mercator, so we know the projection. It is at known scale levels because it jumps. You know, it's not smooth scaling, and these things are not true of Google Earth. And it's really easy to explain to people. So those are our main reasons for doing that. This is for about a mile of coastline. Basically, this group went up. They threw a balloon up in the air, walked it up and down to get enough imagery, and it's hard to see in the projection, but there actually are kind of darker areas of oil accumulation, as well as, you know, in the water, as well as on the beach itself. So you can see discoloration. You can check it out at grassrootsmapping.org/data. There's a lot of links to the raw data, the process data, all different stages, and you can kind of examine it yourself. But this project was pretty interesting. Do you have a question?
How many images in that?
Oh. I don't know. I didn't do this one. This is actually done by Stuart Long of Gonzo Earth. He's also involved in the Burning Man maps, and he's a fantastic map stitcher. But I would hazard a guess 20 to 30. You know, he might have used some more detailed ones that we can't see the edges of to fill in detail, but that's pretty typical.
Can you say the URL again?
Oh, sorry. Grassrootsmapping.org, and there should be big links all over the place to data. This particular project, and there's a slide about this later, but I can just say it now. We try to emphasize public domain publication of the data so that anyone can use it without restriction, without licensing. That's not always the case. When I work with some communities, it's not in the community's interest to actually publish the data. The map is for them, not for other people. And there's a kind of a big distinction in who the map is for. And when you approach a project, I think it's important to work that out ahead of time. So whenever we try to collaborate with people here, we're like, you know, first thing we say is like, all right, everything's public domain, right? You know, and then it's hard to go too far wrong. This is one of our big maps overlaid on a Google map backdrop, which is probably USDA, like USGS, or what is it, the USDA Farm Services imagery, which is public domain. And you get a sense of the difference in resolution. When you drop down to the one-to-one resolution on ours, there's no data to really compare it against. You could manually stretch it, but the OpenLayers viewer won't do that automatically, so it's kind of crazy. But because of the resolution, you can see individual birds on this sandbar, and which I know to you gigapan people is like nothing. You can see bugs in gigapans, right? But I mean, for satellite data, it's pretty impressive. And you can actually tell, like, you know, the species. These are terns. We compare them to ground photos. And pelicans, the larger ones on the sandbar itself, as well as actual oil accumulation near the sandbar. So, you know, obviously it's a small zone, but it's a representative one. This is in the Chandeleur Islands off the Louisiana coastline. And the second part of it is that we can go back there. We can re-image it. And you can see actually coral spots here. And since, you know, coral is particularly sensitive, you know, people have been finding areas of dead coral. Going back in a year's time and making that same map again and comparing, you know, the square area of coral coverage might be a great way to assess damage. As well as erosion due to the dying off of vegetation that holds the sand in place, things like that. So, and then, yeah, I mean, just at the outermost, this is one that we made just by driving a boat all the way up a coastline for about a mile, and went upwind with a kite and downwind with a balloon. So kind of mixed methods there. And when you really zoom in on this one, which I won't do because this is just a PDF, you can see actually the string from the boat going up to the kite, which is pretty nice. I think some map editors would take that out. I actually like to leave that in as a reminder of, you know, how it was captured. And I like seeing myself in the pictures, and I encourage people to leave themselves in them. So there's also, it's hard to make out here, but you can see at certain points. Actually, that string right there. You can also see the wake of the boat at certain points. So yeah, public domain, this is the URL. Not all the data is up there. It takes a little while to actually finish it, publish it, and, you know, get it all sorted out. And I have to say, it's a little messy. We did it through like a Google spreadsheet. So, but don't worry. Part of the reason is that we're actually still processing new data. So every, you know, week or two, a new trip is taken by the Bucket Brigade. New data is captured and brought back. So we're still managing this data flow. It's been going on for months. This is kind of a snapshot of the summer. We try to quantify how often good data was brought back. So this is very crude, but basically we gave each map set a rating of, like, you know, how good it was when it was done. And then we correlated that with, like, who led the trip and where all the data was from. Not trying to criticize, but trying to have good communication between, you know, each end. And then in the reverse, we said, well, what's going wrong? Like, what can we help out with? What you know, you people who have been out on the beaches all day, every day, doing hard work, like, you know, what can you tell us to improve our end? What would be useful? But this is, you know, it's interesting to look at in the sense of, you know, how much was actually pretty good, which I think is pretty high given that the number of people, basically, this represents the number of repeat trips by a single person. So a lot of people, it was only the first time ever doing it. And, you know, for better or worse, they didn't come back. Towards the top end, you had a bunch of people who were coming back over and over and really building expertise in this, showing other people how to do it, et cetera. So I think there's a lot to be learned about kind of the nature of a community that forms around a tool set like this and what drives kind of excellence and how that's defined and, you know, all these things. So, and then, you know, I was mentioning other projects I've done. I've done some work. I'll show a short video which gets some other imagery in there and some zooming around of stuff that's, so we'll get a good look at it. But I mean, one way that I've worked in a lot of different places is by teaching workshops. We've made illustrated guides as a community to show people how to do it in simple steps, made them black and white so you can Xerox copy them. Those are available on the website as well, so it's a 5-page PDF. I recommend you get that. That has everything you need to know to do it yourself. I think I have like 4 out of the 5 pages and 1 copy. I didn't get to a Xerox machine. But I can hand that around. And then just in terms of limits, this is in the country of Georgia over the summer. We flew about 4,000 feet on ocean fishing line, braided spectra fishing line. And that stuff is pretty delicate, so we're actually stopped. We're not going to use that anymore. But it was great because it's super light and super strong. And we threw a GPS on it just to see how high the balloons get. That's actually not useful, particularly for stitching the maps, since we're doing it all manually anyway. And the resolution of the GPS is not really that great. But it's a good morale booster. And that, of course, means you have to be creative in terms of how you reel it back in. It takes forever to reel in 4,000 feet of fishing line. And so we borrowed a bicycle of some kid walking in. It was like, hey, stop, can we use your bike? And we flipped it upside down and you press the reel against the tire as you spin it, and that helps pull it in within about 10 minutes. there's a YouTube video of us using a car to do the same thing. We parked a Jeep like on the edge of a short incline and jacked up the Jeep. Don't do that. It's a bad idea. Or if you do, drive the Jeep in reverse so that if it falls off the jack, it doesn't run over the person. That didn't happen, but it was on my mind. In terms of importing this stuff, I mean, I'm more from like the OpenStreetMap background, I suppose. So we think a lot about how to integrate our products into OpenStreetMap, tool chains. So we have this online stitcher that is the evolution of our Photoshop methodology, and it's basically HTML5 based web, maps orthorectifier. You just upload your pictures one by one. They're thrown up onto a backdrop map that's actually Google or whatever else, and then you can just grab the corners and do rubber sheeting directly in the browser. This is important for people who don't have their own computers or will have to rely on internet cafes. In places like Lima, Peru, where I've done a lot of work, that's typically the case. It also doesn't require a lot of power because all the heavy lifting is done on the server end. So you can do it on a netbook. You can do it over a pretty narrow internet connection. We were doing it over a 3G connection in the mountains of rural Georgia, so the country of Georgia. I don't know how the internet connectivity is in our Georgia, but and then you can export from there directly into TMS Tilesets, things that could be consumed by, say, the JOSM OpenStreetMap editor, which is important in that particular project. It outputs GeoTIFF for those of you who use those, things like that. And yeah, I wanted to acknowledge all the different groups that I've collaborated with and who have supported the project financially as well as in terms of huge amounts of time. There you go. My affiliation is actually with the Center for Future Civic Media, as you mentioned, and they've been really, really supportive in my work. So great. I was going to show this video just because it is, well, videos are just better. Hang on a second. I should let it load in the background. Well, in the meantime, I'm going to hand around the printed version. It's just the first 4 pages. I apologize, a little disorganized. But, and it's pre-worn, but it gives you a sense of like, the step-by-step kind of methods. So pass that around, and I'll throw it up on the screen as well so we can follow a couple of them and assemble a small brief. In terms of the decisions we make, and I'll get into this more as we get our equipment out, but there's often a better way to do it, but that better way, we're making a compromise on difficulty and barrier to entry, and then and expense and such. So I think a lot of kite aerial photographers use very nice equipment that's fantastic, like the Pica suspension, which keeps the camera pointed down. But after a lot of field tests, we found that unless you have done it a few times and you really build experience in that, they tend to be barriers to entry. So we use a soda bottle instead, cutting the soda bottle open, putting the camera inside of that, and just letting it hang. If you put it on a long stick, then you get a kind of a, well, basically it has other stabilization properties which are not dissimilar from the Pica, and it's much easier. So anytime we can make a choice like that, we do. Weather balloons tend to pop. They tend to be about $25 a piece. So we use emergency Mylar sleeping bags, which are they're $1.25 a piece, and you just have to tape over the remaining seam with some packing tape. So anytime we can make a decision like that that slices the price or cuts down on the amount of time preparation, we do. Let me.
Did you have trouble finding helium in Georgia?
Yes, a lot of trouble. It's extremely expensive. Here, I mean, we just went down to a flower shop down the street and filled a few of these things and got a bunch of weird looks, but it's like $55 to fill about as much helium as we could possibly need, which is, it's pricey, but you can take the housing of the camera off if you want to save some extra weight. Or, there's approaches you can do.
I mean, have you thought about hot air?
Yeah, that's the other thing. Let me show you. Here, let me show you a couple of videos, and then we'll have some questions. This will be good. All right, here's a video. There's been a lot of people in different areas testing new techniques, going off in different directions. Solar hot air balloons have been a big one. I've never successfully done it, but other people in the community have. And we have a very active mailing list that I encourage you to join, where people are posting results and such. It's unlisted. I've spent the past year working with different groups around. Maybe we'll have to let it load for a bit, yeah. I'll let it load, and when it's like halfway, I'll play some. In the meantime, so this is the website, as I was saying, and I think one thing to really emphasize is that it's not just like me doing this stuff. It's a number of different groups around the country, around the world, and each one has a specific use case. So it's not developing these tools in the abstract, but really saying, well, here, in Georgia, we can't get helium, so can we try solar things? We tried kites. There's no kite flying culture in Georgia. It's like got left out somehow globally, and there's like a lot of people don't even know the word for kite. So it was like crazy. So it was a learning experience for everyone, myself included. We lost a few, but it happens. So that's the other rule: is like don't put anything up in the air you're not willing to lose. So this gives you kind of an idea of this. That's Stuart Long's blog post about using Cessna overflights. We had a workshop in New York City not so long ago. That's where we actually discovered this thing you can do with the sleeping bags. We hadn't done that before. Basically all kinds of stuff where we're exploring new options, pushing it in different directions. And I think that energy and that commitment to like collaboratively designing things is something that we'd like to scale a bit. So we're beginning to think about new things that are not just balloon mapping, but different ways of seeing the world. Like one idea that we've been floating and working with a group in Wisconsin on a bunch of public school science teachers is an inexpensive thermographic camera that you can image heat leaking out of buildings. We're pretty sure we can build one that costs less than $100. It takes about an hour to take a picture, but I mean, it's still pretty cool, and it could be built by middle school students. So that's kind of in the same spirit of taking pictures or seeing the world in a different way. That's, I think, the way Rich Gibson put it yesterday. It was a good way to look at it. Changing the way other people see the world, maybe, is another way to put it. So we're kind of trying to generalize on this and build what is now a really intense ballooning mapping community into a slightly more generalized community-based research initiative with a focus on specific sites. So that's kind of what we're doing. Cool. Let's ask some questions while the YouTube video loads. Yeah.
Have you played around with the DIY drone stuff?
Yeah, actually, DIY Drones has been really supportive of our stuff. Chris Anderson, kind of the founder of that group, they have different priorities. Like DIY Drones makes little remote control kind of airplane and helicopters that are autopiloted, so they have onboard autopilot things that they actually make the circuitry for and write the software for. It's really amazing. Usually it costs $500 to $5,000, so it's a little out of our price range, but we certainly learn a lot from them. And they have some of the same challenges, such as stitching imagery they capture from their airplanes. So there's been some exchange of, there's a guy named Gary Mortimer who's part of the community. He's actually also in ours. So yeah, they're awesome.
I'm feeling the big elephant in the corner. You keep talking about helium. At more than twice the efficiency, it means it might as well use hydrogen.
Well, hydrogen actually, and it's not exactly my field, but my understanding is that hydrogen forms an H2 molecule, so it's actually only a little bit better than helium. And I would still love to use it, as long as we're not doing it in a workshop with kids. But I've actually I've tried to buy hydrogen in a lot of countries, and it's illegal in most places. But it's, yeah, so there was...
26 for helium?
Yeah, there was one group, what was it?
It's used for gas ballooning in Europe.
Sorry, what was that?
It's used for gas ballooning in Europe.
Yeah, meteorologists are really into hydrogen because it's so cheap. We haven't yet made it in quantities, but we'd like to. We'd like you to also.
Static spark off of
mix.
It's very close.
Was it? I mean, I've seen the ill-advised experiments of people on YouTube blowing up. I mean, that's the first thing I did. I was like, hydrogen balloon explosion, YouTube, you know. And it's discouraging, but I still think that there's a lot to be done there. And I think especially with proper safety precautions, you see a lot of people, there's a YouTube video by some meteorologists doing this, and they wear like some protective gear as they're filling, and they take a lot of precautions, and it seems to be relatively straightforward. Sorry, you've had hand up for a while in the back.
Yeah, just to comment first, in the gas balloons in Europe, they have like a metal conductor on the surface, which would probably be equivalent to the metal coating on the Mylar that you've got. Okay, and then which would lessen your explosion hazard. But I had a couple questions on the Louisiana thing. The one, were the node ends that were in effect an issue? And two, does a rough sea affect the stability of the camera system?
I have less experience flying out far enough from the shore that you get a lot of turbulence, but we did it in the canals a bit, and it wasn't really an issue with either one because there's a bit of elasticity in the line. And in general, things are pretty turbulent, so a little bit more typically kind of just gets lost in the mix, unless you're, you know, the main problem is wind. So, all right, we have 5 minutes. Let's do a few more questions. Yeah. Yeah. Oh, I think you had your hand up.
Okay. Yes. Have you tried the Healy kite yet?
We've been trying to make them. Apparently.
Well, that was my question, because we have one and they're about $1,500 they save on helium. It's really wonderful because they hook a kite up to a helium blimp, and you get the best of both worlds. When the wing comes up, they fly even better, as opposed to a blimp. When the wing comes up, it pushes it over. When there's no wind, it flies quite nicely for about 1.5 cubic meter. But and they have a worldwide patent on that. But I suppose
the patent's expiring this month. Yeah, even if I believed in patents, but
the technology, you think, oh, that's brilliant. Just hook up a kite to a blimp and then you get both. You could make one with kids, I would think.
We've been trying to, and we've had limited success. This is like one attempt which doesn't have an awful lot of lift, but at least doesn't drag the same way that a sphere does. So we've been chipping away at the problem, and I look forward to a lot more workshops exploring that. But yeah.
If you're flying really expensive stuff like 5E warranties and stuff, we've started using barometric altimeters for high power rocketry. Put a cardboard tube, put a parachute in it. If you're above 1,000 feet and it falls through 750 when your kite crashes, it pops out the chute and saves your camera.
We should do that.
I need to squib about an ounce of black powder and a cardboard tube.
Sounds like a pleasure to take on an airplane. No, yeah, I will. Right, yeah. No, if actually we just change information, I'd love to hear more about that, because we've also thought about doing untethered flights that have a known altitude that pop and come back down.
Well, the altimeters are $50.
Okay.
You can get them in quantities of $25.
Okay, cool. That sounds great.
So you're not able to aim the camera with the simple system you're describing, is that correct? It's just pointed down?
It is, yeah. Let me see if I can just bring up the instruction guide. I think what we're going to have to do is I'll throw together a quick rig here, and I'll be outside during lunch, and we can do a flight then, or do what we can. Let me open this the guide up just so that I can show you guys the rig more or less. Yeah.
Yeah, for some of the pictures that you're showing of the Louisiana coastline, how many pictures were in those, and what sort of, how big are the final images?
I think typically we're getting somewhere around like 30 to 50 pictures per stitched image, and I think that's more limited by the amount of imagery and amount of distance you can travel while carrying a balloon during one day, including travel to the coastline and back, and getting enough water and eating lunch and everything that you encounter during a day of mapping. And then typically those images, which have been some of our best, are coming out to be, neighborhood of 30,000 pixels by 30,000 pixels. So not quite a gigapixel, but we're getting there, I think. And the biggest ones have been pushing 50 or 70,000 on a side. So it's pretty big. right, here's the illustrated guide. Okay. Well, why don't we kind of finish up here? I'm going to put this up, and if you guys want to come up and look at some of the equipment, and I'm going to, as we're talking, start assembling things and getting ready to go, and I think that there'll be interesting conversations. So thanks very much.